we use the chain rule when we can't use the product rule or the quotient rule because we have a function inside of a function, not a function times a function or a function divided by a function. So if you look at this first example, I mean the rule is written here. So it says that you take the derivative of the outside term with respect to the inside term, and then the derivative of the inside term, and you multiply those two things together. It can be a bit confusing at first. So we're going to break each of these examples down on this page separately. So taking a look at this first function, for example 1, we kind of want to ask ourselves, what is the inside function? What's the inside idea? So there's a big idea and an inside idea. The big idea is that there's a square root. So we're square rooting something. That's our big idea. So our outside function, I'm going to put g of x. So our outside function is just that we are square rooting g of x. So then our inside function, which is g of x, equals x cubed minus 1. So if we would plug g of x into our f of x function, we would get our original function. So now that we have those two things separated, we can go ahead and apply our rule. But it's telling us that we need to find f prime of g of x. And now this can be a tad bit confusing with the g of x in there. So what I like to do is I like to use substitution. So over here I'm going to say that g of x is actually also equal to u, which means wherever there's a g of x, I can, instead of writing g of x, I can actually replace that and write a u. So f prime of u would mean the same thing as f prime of g of x. And that would mean that I have the square root of u. Now we've already done a lot with square roots, and we hopefully know by this point that that would equal 1 over 2 square roots of u. Alright, so f prime of u is 1 over 2 square roots of u. The problem is we don't want this in terms of u. So we substituted once to make the problem easier, but now we need to substitute again, and we need to make that, turn that back into f prime of g of x, and we know that g of x equals x cubed minus 1. So I'm going to go ahead and just plug that in. So that is our final f prime of g of x, which is the first part of our rule. And then it says you multiply that by g prime of x. Well, g prime of x is just u prime, which is 3x squared. So our final step is to take g prime of x times g prime, f prime of g of x times g prime of x. So if I multiply those two things together, I get 3x squared times 1 for the numerator, and 2 square roots of x cubed minus 1. And that is my final answer using the chain rule. Alright, for our second example, we need to do the same thing. We need to ask ourselves, what's the big idea? So our big idea, our outside function, the big idea just looks like we are taking 1 over the square root of something. So that's our big idea. And then that something happens to be 2x squared plus 2. Alright, so using our rule, remember our rule is f prime of g of x times g prime of x. So we need to find f prime of g of x. And again, I'm going to do what I did before, and I'm going to actually call this u instead, just to simplify the process. I'm just going to do another substitution so I don't have all these g of x's running around. And instead of writing 1 over the square root of u, we know that 1 over the square root of u is really u to the negative 1/2. Alright, so, and actually, I'm going to get rid of that prime because we have not found the prime yet. We just rewrote it with u substitution. Now I'm going to find the prime. And we can go ahead, we can find the derivative using the shortcut. So we have that negative 1/2 down in front, u, and then subtract 1 from our exponent, so negative 3/2. Alright, now again, I don't want this in terms of u, I want this in terms of g of x. So this is going to be negative 1 for our numerator over 2, and then we have the square root, because our fraction's denominator is 2, we know it's a square root, of the quantity g of x, which is 2x squared plus 2, the whole thing cubed. So that's our f prime of g of x. But we have to multiply that by g prime of x. So we go do the derivative over here, And when I multiply these two things together, I get negative 4x in my numerator, 2 square roots of 2x squared plus 2, the whole thing cubed. Now, I notice that this 4 and this 2 can reduce. That goes to 2. So my final answer is going to be negative 2x all over square root of 2x squared plus 2, that whole thing cubed. That's my final answer using the chain rule. All right, for these next two functions, they look very similar, but they're just a little bit different. And so I want to take a look at what happens for each one because this can get kind of confusing with trig functions. So taking a look at this, we're going to take a look at the first one. So this will be our first equation. And when we look at that one, my big idea, like what's the big thing going on? So my outside function, my big idea, it looks like I'm taking cosine of something. So I'm going to call it cosine u. And then that something happens to be x squared. All right, so if I do the chain rule, I'm going to take the derivative here of the outside function, which would be negative sine u. But I don't want the u. I want it in terms of x. So I'm going to go ahead and replace the sine, or the u, sorry, with x squared. So this is my f prime g of x. Now I need to do my g prime, which happens to be u prime with the way I'm doing the substitution. And for my final step, I multiply those two things together. So negative 2x sine x squared. That's my final answer for that first equation. For the second equation, it's a little different. My big idea this time happens to be that I am taking something and I am squaring it. And that something happens to be cosine x. So now if I do my outside function's derivative, that would be 2u. But I don't want it in terms of u, so I replace the u with cosine x. And then I have to find u prime, or my inside function's derivative, which would be negative sine x. And my final step is to multiply these two things together. So it's negative 2 cosine x sine x. And of course we can use a double angle formula and simplify that further if we want, but I'm okay with leaving it like that. So